Auditability, I want to say, is the ability to kind of make sense of what you've observed and track it to a finer level of detail. We built Burr to be a white box framework. We try to make it as transparent as possible for you to see what's going on. We built it so that if you have these production or very customizable concerns, the framework isn't going to get in your way. And I think this is a coming problem that's going to become more important, because if you want to really trust and understand what some sort of AI system is doing, then you're really going to have the observability and auditability to understand which model induced this hallucination.
Hi, I'm Rachel Chalmers, and this is Generationship, the podcast at the intersection of infrastructure and artificial intelligence. We are the generation that's exploring generative AI. We are a finite group of people with a finite set of resources, and we have to share this infrastructure. We have to find fair and ethical ways to do that. The first generation ship has already set sail. It's the planet Earth, and you and I are the crew. This show is brought to you by Heavybit, the leading investor in developer-first startups. To learn more about Heavybit, visit heavybit.com. Today, I am delighted to welcome Stefan Krawczyk on the show. With over 10 years of experience in building and leading data and ML-related systems and teams, Stefan is the co-founder and CEO of DAGWorks, a startup that helps data and AI practitioners move faster with two open-source, production-ready and flexible frameworks, Hamilton and Burr, that he co-created. He's also a Y Combinator alum, a StartX alum, and a Stanford graduate with a Master of Science in Computer Science with distinction in research. Stefan's passion is to make others more successful with data by bridging the gap between data science, machine learning, engineering, and business. He built the self-service MLOps stack at Stitch Fix for 100 or more data scientists that helped generate over $1 billion in revenue. He also contributes to open source projects and advises other startups in the data space. Stefan, I hope you get some rest in between all of that.
Thanks for having me, Rachel. Pleasure to be on the show.
At the core of your Hamilton framework is something called a directed acyclic graph, or DAG. Can you unpack that for us? What's Hamilton actually doing under the hood?
Yes. So directed acyclic graph, which is a computer science term, for those who don't know, effectively means a flowchart that doesn't have loops or cycles. And so it's something that you can express visually. And it's a common way to express, therefore, like how processes and things are connected. You generally hear with those two terms what's called nodes and edges. So nodes being round circles and edges being the things that kind of connect them, right? And that's what you call a graph. And it's directed acyclic, meaning that there isn't any cycles or loops. This is used everywhere, actually, from compilers to things like Terraform. So, Terraform actually under the hood actually creates a directed acyclic graph to know how to execute and apply things.
If this, then that?
Yeah, I mean, or it's more, how does it know how to connect what to do and kind of execute it? DAG's also found in things like Airflow for more data-related kind of things. And so Hamilton's kind of no different here. And the way that it works to create a directed acyclic graph with this kind of flowchart is just by interpreting how you write regular Python functions. And so getting a little bit into the detail here, so I assume people know Python code here. But effectively, you write Python code, and the idea is you write functions. These functions, the name kind of becomes the name of a node. So if you're thinking of this flowchart, you're going to write a name, the function becomes like a node in it. So you write code, write these functions, Hamilton will call a module to pull these out. Now, how does it create the edges? And so rather than you having to specify how functions connect, which is common in other frameworks, you actually just use the same name as the function input arguments. So that way you can read a function named, raw data set, and you can then have a parameter that says, file location as an input parameter, right? And then you can have another function called file location that might, get it for you, or it's required as input. And so Hamilton, the way that it stitches together this graph is just by the way that the names of the functions and the function input arguments. And so that's how it figures out how to link graphs together, but then also figures out how to compute something. So if you want to then compute the raw data set, it will know, hey, I need to find this function, and then I need to go find what it depends on by reading the function input arguments. And then we'll go try to find, in your code base or what the modules you've given it, how do I compute, the rest of the things that are required to, get the raw data set. Unpacked enough?
Pretty well unpacked. Lots of obvious applications to the way we're using AI these days and assembling meta functionality, being able to reason across groups of different functions and abstract yourself at a higher level.
Yep. Yeah, and this is really lightweight. It just runs anywhere that Python runs. So if you think of the kind of graph or DAG abstraction, it's very applicable to AI, machine learning, data, I have even people using it to orchestrate, a little command line interface. So like you can think of it as a make is another way that some people have described Hamilton. So you can kind of do things like a make file traditionally could. It's declarative, declares how you can actually build a DAG, right? With Hamilton, you can kind of do something very similar.
We have to talk about names like Hamilton and Burr, obvious historical references. But, I thought you were an American before I met you. And I was like, oh, he just doesn't know what DAG means. Did you even hesitate about the company name, given what Australians and New Zealanders think of DAGs?
So I want to say I didn't actually understand it. I grew up in the city in Wellington. Though I could see sheep outside my window. I've been in the US since 2007. So in which case, definitely forgot all the colloquialisms surrounding that. And so in which case, for those of you who don't know what DAG is, go Google it and you can find one of the disambiguations and you'll kind of understand. But
also used as a descriptor for a person who is, how should we say, not fashionable, unchic, perhaps.
That must be an Australian colloquialism.
Maybe it is. Australia and New Zealand are two countries divided by a common language. And this is an example.
Yeah, so naming. So, I went to see the Hamilton musical, actually.
Yes.
So learned about the American history. Right? I mean, I want to say, what the two hardest problems in computer science are naming things and cache invalidation, right?
And off by one errors.
Yeah, off by one, yeah. And so I was on the platform team at Stitch Fix, and I was trying to, help a team with one of the issues that they were tripping up over their code base. And I was like, tasked with kind of helping them come up with a solution. I'm kind of on a work from home Wednesday, so plus for no meeting days, was able to kind of think long enough and come up with this kind of abstraction. But what was I going to call it? So the team who I was building it for was called the Forecasting, Estimation, and Demand Team, or the Fed for short. And I'm like, this is foundational. Who founded the Fed in the US? Oh, it was Alexander Hamilton.
The $10 founding father without a father.
Yeah. And then we have, they were modeling the business, so physics is Hamiltonian things, and we're just doing graph theory, which is from computer science, which then has Hamiltonian concepts. So like the confluence of those three things, I was like, great, is a perfect name.
Yeah.
And then more modern kind of, there are other actually relevant Hamilton names. So Lewis Hamilton, Formula One driver. Idea is, with Hamilton is that if you structure code well, you can, and, it's around laps and iterations that wins the race, then Hamilton kind of...
And he's going to be back on the podium next year with his new team.
Yeah. And then also in NASA, there was a lady with a last name Hamilton as well. She was all about software correctness. And so with Hamilton, you have a great testing story. So I want to say they weren't originally in the initial reasons. And then Burr is a little bit of tongue-in-cheek. So those who don't know, Burr actually shot Hamilton in a duel. But with my co-founder, who was at Stitch Fix, we were kind of creating Hamilton at the same time. He was like, no, I don't like this. Or at least I have another idea. And he, tongue-in-cheek, called it Burr. The irony is that Stitch Fix, Hamilton won out over his one. But then the Burr framework we open sourced is, a somewhat, tongue-in-cheek reference to that kind of back in the day of us creating two different frameworks. And in this case, we actually see the new Burr framework as pretty complementary rather than antagonistic, hopefully, with the current Hamilton one. And so in which case, we see them living a nice life together and necessarily one killing the other.
It's a fan fiction where they live happily ever after. I love it.
Yeah.
What are some of the cool projects that people are using Hamilton for? Sure.
So the Olympics are happening this year. And so there is the British cycling team. So British cycling is actually using Hamilton to help with, as my understanding, some of the velodrome telemetry analysis.
Oh, wow.
So they can actually process and, understand and have a better idea of like how they can make a better rider or how they can make someone faster, and just by analyzing and telemetry. And Hamilton helps kind of maintain sanity in that code base of making things testable, documentation friendly, and obviously you can always understand how data connects with some sort of result because you can draw that graph picture. More commonly, people are using Hamilton for feature engineering. So there's various companies and large and small from enterprise that are using Hamilton, say, on top of PySpark to help with feature engineering. So I know consultants are bringing Hamilton into some banks to help with that machine learning AI type stuff. Some are even building more of a machine learning platform since Hamilton gives you a bunch of great hooks. From a research perspective, Hamilton's also, there's a Nature F project by the Pacific Northwest National Labs and Oak Ridge National Labs, a kind of joint effort where if you're trying to predict the weather, you can give it data and that will help better predict the weather. So for cities, the topology of the city actually matters. And so they built on top of Hamilton given some kind of what's called shape files, so files of what a city kind of looks like, it'll process that into the format, then you can kind of plug into this kind of weather modeling system.
Yeah, if people haven't been to San Francisco, we have a different climate every couple of blocks. It's kind of wild and it's all dictated by the shape of the peninsula.
Yeah, and then lastly, more recently topical is retrieval augmented generation systems. So people are starting to build pipelines. So we have one open source project called Ren AI, for example, that's using Hamilton to help structure and bring order to some of the what they're pushing out in open source for people who are trying to build RAG systems.
Yeah, and that's where my mind automatically went, just being immersed in AI 24/7. It seems like people have been talking a ton about observability and explainability for these black box AIs, but Hamilton also supports auditability, which I love. Can you talk about this and why it's important?
So, auditability, I want to say, is basically the ability to kind of make sense of what you've observed and track at a finer level of detail. So with Hamilton, the idea is that because you can draw this graph, this directly cyclic graph, which comes from your code, and that you can then, as long as you track, along with it, the inputs, outputs, the code versions, you have this great audit mechanism, this thing that you can, tangibly go back in time to and understand, okay, given this data and this run, what did it produce? And so with other frameworks and other things, there's a lot of effort required to, instrument observability and auditability for this purpose. But with Hamilton, because of this natural graph structure and understanding how things link, you kind of get it for free. In terms of, auditability, like why it's important, right? I mean, so I don't think it's, Congress was thinking about laws for compliance and governing AI, like being able to really detail and understand how some data came in, went to a model, and made a decision, right? If you don't understand how they connect, you're going to be, stuck trying to audit and verify that, like, hey, this credit decision or whatever this AI decision made, like, what data did it come from? How did it actually make this decision? Auditability also lends itself to good debugging, right? When something happens or something fails, root cause analysis is much easier to do if you can really understand how different pieces of code are connected and how the different pieces of data were generated, right? And so then this can help with reproducibility and debuggability, and then therefore it can help with transparency and accountability. So if you then tack on extra metadata information, it's like, who made this change? Where did it go to? When was the last time this data set was loaded? Okay, when it was loaded, okay, what actually generated it? Then this can help, speed up and give you more trust for, the stakeholders in the business to understand that the data machine and machine learning teams and AI teams are actually, delivering. And then we can actually, if something's wrong, we can quickly go back and go analyze and give, a great response to, leadership to go, we understand why it went wrong and why.
Yeah, even more important, I would imagine, in a multimodal world where your quants are like ingesting results from a whole bunch of different models, at least auditability lets you know that model in particular is the one that's hallucinating here.
Yeah, I mean, if you want that, you basically have to figure out some way to track it. Like my philosophy and thinking is like with the framework, then you get a lot of these kind of easier insights come for free without you having to have every developer or every person writing code like instrument things in a very particular way. Because actually, this is where what the troubles with auditability is that if people have different implementations, they audit things or like they log observability for some information, but for not others, you actually end up with this kind of mishmash of information that then doesn't really help you too much because it's like, people did things very differently. So, and I think this is, a coming problem that's going to become more important because if you want to really trust and understand what some sort of AI system is doing, then you're really going to have the observability and auditability to understand, exactly to your point, which model induced this hallucination.
Back to Burr, you recently got such a lovely comment about your Burr library that I wanted to make sure we talked about it. A Reddit user said, a good library should adapt to you and make your velocity go up. They have an actual concept instead of just wrapping stuff that doesn't need to be wrapped that will save you time because they do the thing they do better than you ever could. Honestly, take a look at Burr. Thank me later. What's the concept underlying Burr that's earning it such great reviews?
I think it's a few things. So one, it's a graph abstraction. So for the technical term, so with the DAG, there are no cycles, but in Burr, you can actually have cycles and loops. And so this means you can do conditional branching. And just so happens that this way of modeling the world helps you think about problems, which just happens to be great for thinking about how agents or bots can kind of, be designed and kind of operate, right? The second is it has a built-in checkpointing and caching mechanism that comes with an open source UI. So from a development perspective, you can get up, you can build this graph, you can immediately see it. And then when it's running, you can actually see what it's doing, right? And so in terms of like, as you're developing and trying to figure out, okay, why did this agent or LLM or thing do its thing? Like that is really easy to see, introspect, and then very easy to recreate that kind of point in time to speed up that development process. Then lastly, I think, which is what this comment is probably getting more at, is that we built Burr to be a white box framework. And what I mean by that is like, we try to make it as transparent as possible for you to see what's going on. So we aren't trying to bundle different concerns that will make it difficult for you to customize for your context, because agents and other stuff, everything's still new. Like everyone's like going to have to customize for their particular concerns, because I know PDFs are very different and you need to, customize how you pull out data from them, or your LLM is going to be different from someone else's, right? And so we built it so that if you have these production or very customizable concerns, the framework isn't going to get in your way. And so this is where I want to say, because Burr is also a very functional type approach, and I want to say, object-oriented approaches generally, I think, help here, and that's kind of what these other frameworks, I think, run into. And so we want Burr to be, the best framework for you to kind of help you run and organize your code, provide the hooks for observability, and so that you can focus on your logic and customization, so you can kind of get the core value of what you're trying to achieve, rather than trying to fight the framework to get it to do what you want.
It's such a beautiful example of, I have this philosophy that code is a reflection of its creator's personality and culture. And, you're clearly both very straightforward and down to earth, and the tools that you've built are all about propagating that transparency and that groundedness.
Yep. 6 years on a platform team, definitely you see all the problems and tools of, a lot of tools, for example, focus on a hello world, super easy, but then they actually enterprise and real gets complex. Like, how do you do, what do you manage? So I've seen definitely the scales of the extremes. And so with both Hamilton and Burr, we're trying to build something for a platform team, but also for a practitioner, and that the operational productionization concerns are the ones that generally slow you down and get in the way and couple you to technical debt, couple you to systems. And so really trying to strive in that way to make it easy to just, if you need to customize it, plug in the observability or the hooks that you need. You don't have to do too much because the framework already provides a lot for you. And then with everything being lightweight and very lightweight dependencies, it's, it shouldn't be difficult to manage, update, change, or update things, since the framework, doesn't bring in the kitchen sink of stuff that, you don't need.
And we're at this really interesting inflection point where, like, so many companies are at the scale that used to be the sole province of the FAANG companies. And the FAANG companies themselves have gone off into the stratosphere even further. But we now have this upcoming generation of platform engineers who need to be able to reason about systems at this very sophisticated level with many, many variables. And it really does feel like a state change, like a significant step change from being DevOps or being a sysadmin.
Yeah, I mean, learning a bit of MLOps, I think, is something that would be useful. So MLOps, I want to see is the general, if you draw a Venn diagram, would cover everything that kind of, Gen AI ops covers. Because in machine learning, you kind of have the same problems. Obviously, things are maybe at slightly different scales, but effectively learning how to deal with something that's probabilistic and generative is one of these main hurdles for platform folks in general to kind of understand, since, running the same prompt and data to, OpenAI doesn't necessarily mean you're going to get the same response back.
And it's so hard for you people from STEM backgrounds. You're like struggling with non-deterministic systems, and us humanities majors are going, yeah, that's what the world is like, my friend.
Yeah. Yep. Yeah, so heavy emphasis on like, how do you evaluate? Like, the interesting part for me is the coupling between guardrails. So making sure your program, the agent or app, whatever you're building is doing the thing that it's doing, but then also with kind of, evaluating it as well. Since, did it do the thing that you said it would do? How do you evaluate, something that's somewhat non-deterministic? Since you can't generally just do equals, and kind of assert equality on things, there's a little bit of fuzziness that people have to deal with. And so learning what is the right software development lifecycle, I think is something that's, how do you incorporate, building those guardrails and evaluations in a way that then, if you do want to make a change, you're going to be confident that you haven't like incredibly broken your app, right, before you ship it, right? And so along those lines, I think, so therefore this kind of the platform ops kind of mentality is really a bit of a zeitgeist, I think, is figuring out how do you build that into your software development lifecycle. That's also not expensive. So you don't want to like ping, OpenAI with a million different messages just to release a product, right? And so people, I've seen, the pendulum has been swinging back and forth as to, how much do you do in CI versus how much do you do after deployment versus how much do you, unit test and spot check and stuff like that.
We're going to have to rebuild all of this. And as an investor, I couldn't be more excited about it.
Totally. I mean, lots of opportunities.
Yes. Yeah. One of the guiding principles of this podcast is that AI should amplify or augment software engineers, not replace them, and should democratize access. As you work to make people more successful with data, is this what you're seeing?
Yeah, I mean, I want to say from personal experience, I actually Copilot has been useful. And particularly in the case of, something that I would potentially spend a few hours trawling Stack Overflow to like, hey, how do I do something? Copilot can generally cut that down a lot. As these tools get better, I think people are finding better context where this generative, because that's what these tools are really good at. It's like generating kind of content given some context. So, I heard some companies like Anthropic internally, for example, has something that helps, scientists or like problem to create better commit messages, because it can not only say, what happened, but also try to guess as to like, why did you do this change, right? Which is very important for a good, commit workflow and commit hygiene. It's not only what you did, but, why did you do it? All right. And so that's cutting people's times down. Like, I'm excited or interested for the unit test case. Like, given some tests, like, can you help me generate some tests, right? And so sometimes it's a little hit and miss right now, but as these things improve, right, then it will cut down the time that it requires, so you can leverage and do more of the interesting work as an engineer versus more of the stuff that we find a little dreary and kind of repetitive. So, for example, creating documentation. So, in open source developer tools, like I'd love to just be able to like run up the class and the spec, and then boom, it could give me the example in the documentation, right? I think,
and have the documentation evolve as the code does instead of getting orphaned when the code changes.
Yeah, or when a pull request comes in, it goes, these things don't match anymore. You guys need to fix your docs, right? I mean, so I'm excited for that stuff to continue to go and evolve. A lot of things that I think from that perspective are just going to help people be more productive. So pull request reviews and other things, making sure you've checked off the checklist, things like that. So definitely will make small teams of developers more efficient.
Stefan, what are some of your favorite sources for learning about AI?
Yeah, so there's a guy called Sebastian Rushka. He has a great newsletter, and he publishes on many mediums. He's also got a good YouTube channel, I think. So I like to follow his newsletter because he does a very good. So my background is kind of machine learning. So I want to say the content is still pretty accessible. He basically takes research, distills it, and tries to just give you kind of a small overviews of how models and things are working. What's some of the techniques that are happening? Since he reads the research papers and tries to summarize and kind of do stuff. Otherwise, Andrej Karpathy. So Andrej Karpathy has a great YouTube. If you really want to know things from first principles, he really has a great series of like building an LLM from scratch.
He's amazing, yeah.
And so if you really want to understand something at a basic level, and like, because some of this is, it's easier to understand if you can track the evolution of what was the initial thing to what it is today. And that's kind of what he walks through. So definitely +1 for Andrej's YouTube. And then from a practical standpoint of things, like how do you actually build apps and get it to production? I have some former Stitch Fix colleagues, Brian Bischoff and Jason Liu, who tweet on X, formerly known as Twitter. And so they definitely generally have some, maybe sometimes some snarky comments, but generally put out posts and things that are around more of the practical, like pragmatic side of like, well, this is how we build apps. No, you don't need anything too complex. This is kind of what we did type thing. So they're useful from like if you're building it and you want to like understand, more from a pragmatist kind of perspective, how to do stuff. They're worth a follow.
You got to get them on Mastodon. That Fediverse is the future.
Sure.
Speaking of, if everything goes exactly the way that you would like it to for the next 5 years, what does the future look like?
Yeah, so to me, composable AI, right, is like hopefully something that's achievable, and we then trust the systems that are going to output. So for me, because composable AI means like, so we have AI and they're going to build on top of each other to do things. So if you think of, I want to create a list of potential people to reach out to, I might have an agent that scrapes the web. I then might take what they have and then enrich it by, figuring out or trying to, collect and augment things. And so you're going to have these little agents or AI things. And so to be able to use them, you need to be able to trust them. And so this is where I think the introspection, observability, and the importance of auditability to really understand how these things are operating and are working will then give you the confidence that like, hey, if it gives you an email and this is the bio, that like they haven't screwed up, right? And so the only way to do that is if you can peel back the onion, so to speak, have a system that then you can kind of see how things connected, where things kind of either went wrong or what decisions it made. And so for me, hopefully this is built on the back of Hamilton and Burr, obviously. A little bias here. Hamilton for the data-related work, because I think you need to ingest data somehow. A DAG is a great representation of it. Hamilton can help standardize. And then, providing the introspection, observability, auditability, right? You can then have the base building blocks to build that stack. Similarly for Burr, since, you can describe agents, you can build applications, both of them, as we said, I want to say complementary, in which case, whoever's building these things, we should have like a management type interface where we have these agents as assistants. They're doing some work for you. And then if you can thumbs up, thumbs down, or approve things, or say, no, that's wrong, and it'll go back. Or you can even just, rewind and go, actually, sorry, I didn't give you enough of a specific command. Let me fix that and then have you restart again, right? And so that's the kind of, in my mind, in 5 years, like Apple was already, demonstrating with like things on its computers to do this. And so in which case, I feel like everyone's going to be having something like this. And for me, hopefully off the back of Hamilton and Burr. But then the one personal thing I'd love is, an email assistant. So someone to help, easily filter and then auto draft things that I can then just go tweak, change, update, and then that'd be lovely.
Select all archive is your friend. Last question, my favorite question. If you had a generation ship, if we were all on a beautiful colony ship on our way to Alpha Centauri, what would you call it?
Yeah, good question. The way I like to name things is to kind of think of what does that spark in my mind, right? And so I was thinking words like, foundation, core, I guess, beginning. In my mind, those all words, like come together as I'm thinking of something called like, seminal one or something. Because if the point is to go forth and populate and spread and be the first of its thing, that's probably, sounds spaceship-ish to be as well. So seminal one.
It's a great one. Stefan, even though as a New Zealander, you are my natural enemy, it's been delightful to have you on the show. Thank you so much.
Much appreciated, Rachel. Hold nothing against Australians. Happy to speak again.
Thank you. That's all we have time for today. If you're interested in being a guest or if you know someone awesome I should interview, hook up with us online. We're available where all fine social medias are sold. This show is brought to you by Heavybit, the leading investor in developer-first startups. To learn more about Heavybit, visit heavybit.com.